Hey there, 4th grade! Today's mini lesson is on comparing fractions when both fractions have to be changed to an equivalent fraction. Yesterday we did it when one had to be changed. Today we can do it when both do. After you have written this down as the next page, next title on the next page on your math notebook, close it up and concentrate with me on the I do. Okay, so yesterday we compared fractions like 3/4 and 5/8. And let me remind you how we did that. To be really sure that I'm right, I can only compare fractions with the same denominators because it's just easy to count parts. If I were to draw 3/4 and 5/8, they're pretty close. And so I can't be absolutely sure just from a drawing that I've got it. So my safest and best possible strategy is partition drawings. So what we did yesterday is we said, okay, well, I'm going to draw my fraction that has the smaller denominator, fourths. And I'm going to partition it up to the one with the greater denominator. So if I cut my fourths in half, now if I'm looking at 5/8 and I'm looking at 3/4, I can say, well, 3/4 is 1, 2, 3, 4, 5, 6/8 when I partition it, and it's really easy to compare 6/8 to 5/8. Obviously, 6 is more, right? So today we're going to run into a little bit of a problem with that strategy, and let me show you how it works. So let's do this one. It says, Maddie finished a half of her reading minutes on Monday, and her best friend completed 2/3. Who completed more? Now, you may be able to tell what the answer is just from the question, but I want to show you how that last strategy of partitioning one fraction so they both have the same denominator of 8, how it works in a situation like this. Because what I told you to do yesterday, I said, okay, we're going to compare a half, and we're going to compare 2/3, and I'm going to take my smaller denominator, draw it out, and I'm going to have to partition that into thirds. But the problem is, if I cut it, even if I partition it once, I'm already have more than 3 parts. I can't partition this into thirds. It's not possible. And so when that's the case, and we want a really careful comparison where they have the same denominator, I'm going to have to partition them both. So I'm going to leave 1/2. I'm going to also draw 2/3. One, two. So there's my 2/3. And in order to get a new fraction, I'm going to have to get a new fraction for both of these. So I tried trial and error here. So I tried partitioning this once. I got fourths. I don't have any way to turn this into fourths. I can't do that. So let's try partitioning this one once. And now I've got a new fraction here, equivalent new fraction of 4/6. So, well, I wonder if I can partition this one into 6 pieces. And I can. If I cut this one twice, now this is 1, 2, 3 out of 6 parts. And when I have the same denominator of 6, it's really easy to tell from the fractions which one is greater. It's very obvious to me that 4/6 is greater than 3/6, but sometimes to tell, you have to partition both fractions. All right, let's do one together. All right, 2/6 of RD head students are morning car riders. 1/4 are afternoon car riders. Are more students morning or afternoon car riders? So let's see which of these two fractions is greater. So we've got 2/6 and we've got 1/4. And what I always told you to do before, I'm going to write this down, is I would say, all right, well, draw your 1/4. and cut it so that you end up with sixths instead of fourths. But as soon as I cut it, I already have more than fourths. I already have more than 6. I already have 8 pieces. No good. So I can't turn this into sixths. So I'm going to have to partition both to get a new denominator that matches. So let me draw a 2 6. Let's see, that's half, and then 2 more, I think. So as you can see, these fractions are going to be pretty close in value. And these strategies of using the partition drawings is especially for when they're close. Number lines were fine when they were nowhere close. These are pretty close, and I want to make sure I'm exactly right. So there are my 2 fractions. And if you want to write, I said I need to partition both into fractions with same denominator. If they both have the same denominator, it's very, very, very easy to tell which one's greater. The problem is I don't know what denominator I'm looking for. So what I can kind of think here is, don't write this yet, just think with me. I can cut this once and get eighths. I can cut this twice and get, 1, 2, 3, 4, 5, 6, 7, 8, 9, some of 12s. I could cut it 3 times. And get 16ths. So I can either cut that into eighths, 12ths, or 16ths. And over here, I notice if I even just cut this one once, I'll get 6 pieces. Now I'll get 12 pieces. And this one I could do 12s too. So I think I'm going to cut these into 12ths. So I'm going to cut that into one line, partitioning it into 2 pieces. And I'm going to get 4 12ths. And then to get 12ths here, I had to partition twice. 1, 2. When I partition that twice, I get 3 12ths. And I can tell, once the denominators are the same, look how easy it is to tell which one's greater. Even though they don't look really the same the way we partitioned them, 4 12ths is obviously more than 3 12ths. So, more students are whichever one 2 6 was. Morning car riders. And that's the strategy. Same strategy yesterday, you just have to partition both fractions, and then you get a really clear answer. Alright, if just 2 examples was not enough, go ahead and watch this one again and the last one again. Once you really feel like you understand this, you've written the we do down in your notes, and you got this, you're all set, and I'll see you tomorrow.